Today's lesson is relations and functions. Our objectives are to identify relations and functions and to evaluate functions. Sometimes the relationships do not add up to a function, so we're going to discuss what a relationship. A relation in math is a set of ordered pairs. So what we're used to as an ordered pair is an XY. That's a relation. It's an ordered pair. Remember, the X always goes first and then the Y. So this chapter is mostly, I bet, about graphing. So we're going to be graphing on a coordinate plane. And this is your X line and your Y line. And when you graph these ordered pairs, you're going to start with the X line, and that will either go left or right, so that will be your left or right. And then for your, the Y, it will either be up or down, depending on if it's a positive or negative. Left is negative, right is positive, up is positive, and down is negative. Okay, another way you could tell whether a relationship is a function usually is just a line. It can be what's called a U, and that's called a parabola. There's certain kinds of functions you're going to be looking at. A parabola, you'll have some that look like lines. Here's what a line looks like. It's down at the bottom of your page. And then if you also, a function also will be like a U. And then a function also kind of like a U. It's not really a, that's called a parabola. And that's a function. And then other functions are that the points don't overlap on each other on the X line. So we'll discuss that in a second, what that means. You can use what's called the vertical test. We'll use what's called the vertical test. I use a pencil, but I don't have a pencil with me, so I'll use lines or something like that, my finger or whatever. You won't be able to see exactly how I do it, but I'll show you what I'm talking about. And then a function is a function notation when you use f of x. That's called f of x. I also call it y. We're going to use in a formula very soon. It's called y equals mx plus b, and that is called the y-intercept form. That also is called a function. It's a line. F of x is another way of saying it. The f of x means the function of x. And other variables might be used for the function. Like I used y here. They might use a or b on your homework assignment or even in our examples today. But y is mostly what you'll see from these chapters on. Okay, use a mapping diagram to determine whether each relation is a function. So, I'm going to show you what I'm talking about, a mapping diagram. That means you have something that looks like a box like this, and you have two of them. This will be your x points, and this will be your y points. So all of these are your x's, the first numbers in each of these paired. And you are going to start from smallest number to largest. No repeating. No repeating numbers. Ever. If there's repeating, just keep it at one number. That's okay. So you're going to put down 11 is your smallest x, so I'm going to put 11 there. And then I have 12, so I'm going to have 12. Then 13, 13. And then 20, 20. Now we're going to do our y's. The same idea. Do not repeat numbers. So as you could tell, you start with your smallest number. And your smallest number is -2. Then I have a -1. I have another -2, but I already have a -2 on the y, so don't redo it, just leave it. And then you have 7. It's okay if you have not all this, you have less numbers in one than the other. That's not a problem. Okay, this is where the function comes in. You're going to have what's called a arrows. We're going to arrow it. So I'm going to say 11 goes to, you look at the first point graph section, first point, and I notice that it goes 11 to 2, negative 2, so I'm going to put an arrow from 11 to negative 2. And then I go to the next one. It says 12 to negative 1, an arrow to there. Then I have 13 to negative 2, goes back up here. And then 20 to 7. Okay, now, to say if it's a function or not, I'm going to look at this box right here, the X box, and see if each number has its only one line attached. Well, 11 has only one line attached, 12 only has one line attached, 13 has only one line attached, and 20 does. So since it has only one line attached, they're a function. Let's look at B. So I have, you're going to write your 2. Smallest number here again for X is negative 2, negative 1, and then 6. Again, negative 2 comes up again, but that's okay. We just leave it, and now we do the Y's, and I have negative 1 is my smallest, then 0, then 1, then 3. Now I'm going to do my arrows. Negative 2 goes to negative 1. Negative 1 goes to 0. 6 goes to 3. And negative 2 goes to 1. Okay, again, I'm looking at just the X1. Negative 2 has 2 lines going to it, and because it has 2 lines going to it, it's not a function. We'll be graphing this and showing you a different way of doing this so you could see why it's not a function or it is a function. Okay, C. Again, you have your 2. My smallest number on X, remember it's X, we have these. 2 is my smallest. And then I don't have a 3, a 4, a 5 I do, a 6 I do, a 7 I do, and a 6, 6.5 goes before 7, so I'm going to put a 6.5 and a 7. And then I have 0. My smallest number is a negative 1. I'm going to make that a green number 2 again. I have negative 1. And then I have another negative 1. Don't need to rewrite it again. 0. A 2 and a 6. Now I'm going to put my lines. 2 goes to 6. 5 goes to negative 1. 6 goes to 2. 6.5 goes to 0. And 7 goes to negative 1. Okay, again, I look at just the X. And each one of them has only one line attached to it, so it is a function. The Y's over here can have as many lines attached to it as it possibly wants to have. Okay, on your homework you're going to see that. It can have as many lines attached to one number as it wants. But it's still a function if all the numbers on the X have just one line attached to it. Let's try it in another way. Another way to do it is by graphing them. And I'll show you what a function looks like when you look at it on a graph. So we're first going to graph them. I'm going to put it on pause and graph, so why don't you pause and graph your point. Okay, so I've graphed all the points for A and B. And to do the vertical test, remember the vertical test is going up or down. So this is my yellow. This will be your version of a pencil. All right? So I'm going to check and see if it's a function or not. You only need 1 point vertically on a line. So if I look at the first point, and I have on each of these lines, okay, on the first line closest to me, it has 1 point. So that's okay. The second line has got 1 point. That's still okay. Third one, I have 1 point on it. That's still okay. But on the fourth line, I have 2 points on the same line. So that is telling me it is not a function. So to have a function, you need to have at least none of them have the same x. And that's what a function means. So this is not a function. If I look at B, again, I have my vertical lines. And there's only 1 point on all 4 lines, so that means it is a function. So that's how you do that one. So let's look at example 3. All right. So you're going to make a table. I made a table for you, and it also told you to use what numbers to use. It says make a table for each, and I would like you to make a table that kind of looks like what I have down here. And what you're going to have is they say use 1, 2, 3, and 4, so I put 1, 2, 3, and 4 in the inbox. And then I took, and that's my inbox. And then in the middle will be your equation they want you to use. And that's the equation they want you to use. And this will be your answer. And that's all you're going to do on this one. So I've got my stuff, my box ready. So they told me the numbers to use. So 1, 2, 3, 4. So I'm going to plug them in. It's going to be -2 times 1 squared plus 7. And that will be -2 times 1 is -2. Plus 7 is 5. So -2 times 2 squared plus 7 equals, so it's 4 times -2, which is -8 plus 7 is -1. -2 times 3 squared plus 7 equals 9 times -2 is -18 plus 7 is -11. -2 times 4 squared plus 7. 4 squared is 16 times 2 is -32. -32 plus 7 is -25. I'd like you to try B on your own. Please put me on pause, check it out, and see if you got them right. Here's your answers, 5, 2, -1, and 4. Okay, example 4. Find the range of the function rule and given domain. So this time they gave you the domain, and you are going to plug those numbers in to find the range. Domain just means your x's, okay? Or for them they said A, but it's really the x points. So you're going to plug them in. You're going to go -3 times -3. I plugged in -3 right here, plus 5. -3 times 1 plus 5. You're going to have 3 answers, and -3 times 4 plus 5. So they give you 3 numbers. You're going to have answers of 3 numbers. So here are your answers. Okay. So here are your answers, 14, 2, and -7. And what they want you to do is put it from least to greatest. So your least number is -7, then 2, and then 14. And you put these type of brackets around it. Okay, B, I already did for you. It's 5, 1, and 26. Look at how I put parentheses around them because you're getting squares and stuff like that and squaring things. So your answers are 5, 1, and 26. You put them from least to greatest, so it would be 1, 5, and 26. And there's your answers for example 4, A and B. All right, goodbye.